This lesson is going to go through a few example word problems using a system of two equations. So our steps for these word problems are pretty much the same as when we were using a single equation. We still start out by reading carefully to determine the unknowns and identify those unknowns, represent them as variables, use our given information to write equations. So now we have another tool in our toolbox in that we can use two equations and two variables, and we can keep them as two equations and two variables. And then we're going to solve that system of equations using any of the methods that we've learned, usually substitution or addition, subtraction. Always remember, check your answer and check several things. Check that your steps make sense, check that both equations work, check that you've actually answered the question, and check that it actually is a reasonable answer. Does it make sense? Don't forget to write a statement on these. So our first example, we have a contractor paying 13 people. We've got a total value of the work. We're told some are carpenters, some are helpers, and we're told how much they each make. So our unknowns: number of carpenters, number of helpers. And remember, be specific with these unknowns. Don't just say carpenters, because then it's not clear. Is it the number of carpenters? Is it how much they were paid? Is it how much work they did? Right? So be specific. So we have two totals in this question, right? We have total people and we have total paid. So the total people, carpenters plus helpers, equals our total people. So C plus H equals 13. Total money is a little trickier. So remember, with these ones, when we're looking at a total that depends on how many, we take the value, or the cost, times the number of people, or the number of objects in some questions. So our value, the amount being paid to the carpenters, is 1,200. So we multiply that by the number of carpenters. The value for the helpers, 840. So we do that one. So, and then we get our total value. Now the second equation is kind of big. So sometimes you might want to look at, can I reduce this value? So when we looked at our addition subtraction, we know we can multiply an equation as long as we do to whatever we do to one side, we do to the other side. We can also do that with division. So these ones, they all end in 0, so we could divide everything by 10, and that's a little bit better. But you might notice, hey, those ones are all divisible by 4. Remember, our divisible by 4 rule is if the last two digits are divisible by 4, the whole thing's divisible by 4. So if we do that, we get 30C plus 21H equals 354. And then you might notice, oh, those are still divisible by 3. Remember our division by 3 rule. If the digits add up to something divisible by 3, it's divisible by 3. So 3 plus 5 plus 4 is 12, which is divisible by 3, so we can divide that by 3. So if we divide those all, we end up with 10C plus 7H equals 118. So 118, still kind of big numbers to work with, but a lot more reasonable than the equation we started out with the 1200C and 840H equals 14,160. So if you see that you've got a question with some pretty big numbers, you're like, I don't know how to handle that, see if you can reduce it. Now you don't have to reduce it, it is an option. So once we've got those equations, whether or not we reduce them, we can solve them by whichever one of those methods. So I'm going to do this first one using substitution. I'll do the second one using the addition subtraction method. So if with substitution, I can see I already have C plus H equals 13. It's pretty easy to solve that one for either C or for H. We just bring the other variable to the other side. So I solved for C. And then I took that 13 minus H that resulted, and I plugged it in wherever I had a C in my other equation. So that becomes 10 times 13 minus H plus 7H equals 118. Distribute that 10 to get rid of the brackets, and then we have some like terms we can get together. So negative 10H plus 7H is going to give us negative 3H. We can also bring the 130 to the other side, to give us negative 12. And then lastly, we want to get our h completely alone, so we divide both sides by minus 3. We get h equals positive 4. Remember, on these questions we do have two variables. We've solved one of them. To solve the other, we substitute back in to one of our equations, and I'm going to substitute back into this rearranged first equation because it's just going to be 13 minus 4, which gives me 9. Now, that seems like reasonable answers. We're talking about people, so it makes sense that we ended up with whole numbers, 9 in the one category and 4 in the other. We can also check that the money works out. So if I have 9 people getting paid $1,200 and 4 people getting paid $840, I can do that multiplication and see, yes, it does work out to the total that they were supposed to be paid that week. So once I've done my check, don't forget, write a statement. So in this case, there were 9 carpenters and 4 helpers adequately answers the question. In fact, it goes a little further because the question really only asks the number of carpenters. Second question involves a little extra equation here. We've got speed equals distance divided by time. So when we're given a hint like that, we know we're going to have to use it somehow. Reading through the question, we can see that we need to know the speed of the stream's current. We're not specifically asked it, but we're also going to have to figure out the paddling speed. So that's our two variables. Now this one's a little tricky, so you might want to pause and think about it for a moment. What are the pieces of information that would give us two equations for these two variables? And my hint for you is that we're going to have one equation for going upstream and a different equation for going downstream. So if you think of what's going on, upstream they're paddling against the current. So if I take the current speed and I subtract the paddling speed, I'm going to get the speed they're going at. Actually, I've got to do that exactly backwards. It's the paddling speed minus the current speed, which tells me I've got a mistake in my calculations. So I'll have to fix that as we go along. And we know that it took them 8 hours to get that 40 kilometers, so here's where we can use that speed equals distance divided by time. Right, 40 divided by 8 is the speed they actually traveled at, so they traveled at 5 kilometers an hour. Downstream, they did exactly the opposite. They got C plus P, right? They're going with the current, and it makes sense it didn't take them as long because they're going with the current, and that they were going faster overall. So 40 divided by 5 gives us 8. So when we've solved that, we can see that we can line these up. So if I rearrange that second equation to P plus C, my C's line up with my P's. And so I get, when I add them up, my C's are going to cancel, my P's add up, so I get 2P equals 13. So I can solve for P to be 6.5 kilometers. I can substitute that back into my original first equation to solve for C. So we get 6.5 minus C equals 5. I can move my C to the other side to make it positive, move my 5 to the other side so I can add like terms, so I can get my current speed. I can check that in my downstream total, right? They add up to get 8 equals 8. So I know I did things correctly. So that tells me that I can write my statement. The current speed was 1.5 kilometers an hour and the paddling speed was 6.5 kilometers an hour. Now this time we didn't end up with whole numbers. That's okay, because we can have decimal values. when we are talking about speed, so that makes sense. And in fact, the question told us nearest tenth of a kilometer, so that was a big hint that we might end up with decimal values. So do check that if you end up with a fraction or a decimal that it makes sense, but in this case it does. In some cases it would not. So if you end up with a fraction or decimal and it doesn't make sense, go back and double check your equations and your work that they make sense. Now if you're looking at, are these reasonable, they are pretty low speeds, but if you consider the fact that it took them 8 hours to get 40 kilometers, these guys were not traveling too fast. They were taking it easy. We're going to assume they were fishing along the way. Okay, so the last one that we're going to look at, we've got another one where we're looking at two kinds of totals. So we've got a mixture of two things, that should be plural, and we're told the total that they're sold for. So the two things we don't know, kilograms of each of these substances, so kilograms of cashews and kilograms of pecans. So our one total, add up those kilograms to get our cashews plus pecans. But we can also add up the cost. So remember, cost, we're going to have to take the price per kilogram times our kilograms, which we don't know, but we've got a variable for it. So we end up with 4.4 times C plus 4.9 times P for the cost of the cashews and the cost of the pecans respectively, or pecans if you prefer. So this one we ended up with some decimals in this equation because our price was including dollars and cents. So if you want to eliminate those decimals, we can move that decimal over by multiplying by 10. Whatever we do to one side, we also have to do to the other. So we end up with 44C plus 49P equals 328. You might say, I don't mind working with decimals, so you might leave it with the decimals. That's okay too. So we've solved one by substitution, one by addition and subtraction. I'm going to say pause the video, solve this one, whichever method you choose. When we continue, I'm going to solve it by substitution. So I rearrange that first equation to get C equals 7 minus P. Substitute that into the second equation, so wherever I had a C, I'm putting in 7 minus P. Get rid of those brackets. Get our like terms together. Lastly, don't forget to get your variable completely alone, so divide by the coefficient, in this case 5. So we get P equals 4. So this one did work out to a whole number, but given that it's kilograms, we could have ended up with a fraction. So to finish our calculation, we have to substitute this back to find our kilograms of cashews. So we get 3 kilos of cashews. We can check in the cost. The cost of the cashews is working out to $13.20. The cost of the pecans is working out to $19.60. I'm going to say these are some old values. You cannot get cashews or pecans for that cheaply today. So we do that and we see that it does work out, so we can write our statement. The mixture was 4 kilos of pecans and 3 kilograms of cashews. So that's the last one I'm going to do together on video. I am going to ask that before our Blackboard session, you try doing the 3 I've highlighted in purple here. So question 6, question 10, and question 12. And we'll take those up together in class.